that. All right, well, let's get started. The roll sheet is being passed around, so make sure you sign the roll sheet when you're here. If you're here, of course, this is just to annoy people who are listening to this but did not show up in the class. Your homework assignment, nested loops, was due today, about 51 seconds ago. And yes, I tend to be pretty precise about time because my watch is synchronized to the atomic clock. So it's accurate down to at least milliseconds, if not better. My server is also synchronized to the atomic clock, so that's why I know exactly when the server will stop accepting homework assignments and stuff like that. So the first thing we'll do is to go over the homework assignment, nested loops. I will work out the solution, save the file to today's folder. I did not upload the folder from Tuesday. I forgot to do it, but the video is up, is online already. Are there any questions before we go and try to do the nested loop homework? No questions? Everything is good? Okay. All right, so let's go ahead and get started with this homework assignment. The class actually has 51 or 52 students, but for some reason, with almost every homework assignment, I only get like 47 or 48, submissions. A few people are always missing. I'm not sure whether they are the same people or not. I just recognize that it never gets to the full number, the number of students in the class. All right. So same thing, same with all the other homework assignments. You download the file first, and then you work on it. So we'll go ahead and just download this, save link as, and we'll put it into today's folder. Right there, and I'll keep the name nested. And you open it up in LibreOffice 3. And if you come in late, you are responsible to make sure that you sign the roll sheet. I am not responsible for that. All right, so this is the homework assignment, and it is almost the same as the one in the book or in the notes. Okay, so for the most part, all the points that I went through in the book or in the notes, would apply to this one as well, except the way I update the variables is a little bit different in the homework assignment compared to the one in the notes. Other than that, the control structure or the structure of the loops are almost identical to the one in the notes. In other words, I did not make it as hard as I could have been, because I want people to kind of ease into this gradually and not get too discouraged. Any questions? You guys okay? Okay. All right, so let's go ahead and trace this. I was even kind enough to give you all the headings so that you don't have to type the headings of this particular trace. So here goes the precondition. Now, when you talk about the precondition, you have to go back into the homework assignment and check with the description to see if I want you to start with any specific precondition. Okay, sheet 1 of the spreadsheet contains the algorithm. Sheet 2 will contain the trace. Assume that we don't know anything about the variables. So that tells you that you have to start with question marks, okay? So that's why you have to read the instructions carefully. And now we can start with line 1. So let's pop up the other one, and we can go from there. Okay, line 1 is a simple assignment statement. 0 goes to z, so z gets updated to 0. Line 2, x gets 0. Line 3, it's the beginning of a pre-checking loop, which means we have to evaluate the condition, and then we have to answer the question, is it true or is it false? In this case, it is true. X is 0. 0 is less than 3 is true. So we go into the loop, we enter the loop, and we end up on line 4. Line 4 is going to put a 0 into y. Then we move on to line 5, which is the beginning of another loop. This is the inner loop. 1. 2. 3. 4. 5. 6. 7. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. 31. 32. 33. 34. 35. 36. 37. 38. 39. 40. 41. 42. 43. 44. 45. 46. 47. 48. 49. 50. 51. 52. 53. 54. 55. 56. 57. 58. 59. 60. 61. 62. 63. 64. 65. 66. 67. 68. 69. 70. 71. 72. 73. 74. 75. 76. 77. 78. 79. 80. 81. 82. 83. 84. 85. 86. 87. 88. 89. 90. 91. 92. 93. 94. 95. 96. 97. 98. 99. 100. 101. 102. 103. 104. 105. 106. 107. 108. 109. 110. 111. 112. 113. 114. 115. 116. 117. 118. 119. 120. is also true. Oh, I made a mistake here, didn't I? It is false. Because at this point, y is 0, and so is x. 0 is less than 0 is false. So what do we do when the condition of a pre-checking loop is false?
And while.
We go to the end while, or we get out of the loop. Okay, so in this class, we don't trace line 8 because line 8 is ambiguous. So we go straight to line 9. Line 9 is incrementing the value of x. X goes from 0 to 1, and then where do we go? 3. And then we go all the way back to the beginning of the outer loop, not the inner loop. Okay, so the beginning of the outer loop is line 3. So here we ask the same question again. Is 1 less than 3? The answer is true. Then we go to line 4 again, and y gets 0 one more time. Okay, I want people to indicate that y gets a value of 0, even though it was 0 already, because it is important to recognize that line 4 does, make changes to that variable. Now we move on to line 5. Line 5 is the beginning of the inner loop, which asks the question, y is less than x. Is it true or is it false? True. It is true this time because x is 1, y is 0. So we have to get into the inner loop onto line 6. Line 6 is adding 1 to z. Z goes from 0 to 1. We go to line 7. Y gets incremented from 0 to 1 as well. And then where do we go?
5.
We go back to line 5, okay? Because this is a loop again. At the end of a loop, you always go back to the beginning to check the condition to see whether you have to go for another iteration or whether it's time to exit the loop. So we go back to line 5, and then we ask the question, y is less than x. Is it true or is it false?
False.
It is false this time because both x and y have the value of 1. So 1 is less than 1 is false. We get out of the loop. We end up on line 9, which adds 1 to x. X goes from 1 to 2. We go back to line 3 again. X is less than 3 is true for the last time. And then we go to line 4. Y gets reset to 0. Okay. And then we go to line 5. And this one is a little bit longer. So I'm going to have to split the screen so I can show the heading of the trace and also work on it at the same time. On line 5, we have to evaluate the condition. Y is less than x is true because y is 0 and x has a value of 2. We go into the loop onto line 6. We add 1 to z, and z was 1, so now it is 2. We go to line 7. Y gets incremented from 0 to 1. We go back to line 5. Y is less than x is still true. Go to line 6. We add 1 to z again. Z goes from 2 to 3. We go to line 7. Y gets incremented from 1 to 2. Then we go back to line 5. Y is less than x is it's false this time because 2 is less than 2 is false. Then we get out of the inner loop. We continue onto line 9. We add 1 to x. X goes from 2 to 3. Then we go back to line 3 again. X is less than 3 is now false because x also has a value of 3. And then we go to post, and we're at the end of this trace. Okay, so the way I grade this is pretty much all or none. If it doesn't work, you get 0 points. I'm just kidding. Now, but you do have to remember, I'm doing this only because this is a class. If you're working as a developer, as a programmer, and your program does not work, then it does not work. Okay, your boss will probably fire you, if you have enough of these things, going on. So in a class, I'm looking for key concepts in this case. In other words, what I'm looking for is whether someone has an understanding of what loops are. Okay, what I'm looking for are transitions from this line to this line. The condition is true, you enter the loop. I'm looking for transitions like this. The condition is false, you get out of the loop, even without entering one time. Okay? I'm looking for transitions like, let's see, where from here to here. Okay, I'm looking for transitions like this at the end of a loop. Do we know where to go? Do we get out of the program altogether here, or do we go back to the beginning of the loop? So I'm looking for these concepts. If someone makes careless mistakes like updating 1 to 1 again here, some points will be deducted, but it won't be too much. Okay, because that's basically careless mistakes. As long as that person still shows me the flow of the control is correct, that person will still get the majority of the points. Are there any questions about how I would be scoring this? Yep, go ahead.
Actually, when you go on Moodle, how do you find your homework grades for the previous time?
You go to grades, or you can go back to the homework. The homework itself will also show the score that you received for that homework. But if you go to your grade book, I think it's under quote-unquote administration, and it's under grade. You can actually see your attendance, records, and everything else.
Oh, okay.
Yep. Okay. Yep.
I just have a question about the transition from, okay, it was online.
Okay, tell me which roll
13
number.
on 13?
Okay.
Oh, sorry, 13, like, the actual 13.
1-3.
1,
Sorry?
3. 13, like 1, 3, not 15.
Oh, sorry.
It's okay. How we jump from 7 or line
Back to
7
5?
yeah. Why? I don't
Because line 7 in the algorithm is the last statement of the body of the inner loop. So after you perform the body of a loop, you have to go back to the beginning to reevaluate the condition to see whether you need another iteration or whether it's time to get out of the loop. Yep. Okay, so any questions? Any other questions? No? Okay. So this one is a little bit long, but I don't think it is really that long. 27 lines is not too bad, especially you don't have to handwrite everything. So for the most part, it's just entering these numbers and making sure that you follow these things. The only time someone will not get partial credit would be one, there's no partial credit to assign, which means that person got this completely wrong. Okay, all the key points that I'm looking for are all missing. Then that person may not get any credit. The second case is when I suspect that person is copying the homework from somebody else. So those are the only two cases where I would not give any partial credit at all. There's a third one. Okay, the third one is obvious. Someone did not turn in anything, which is happening to about 3 people in this class, because I know from the row sheet that we have 51. So I think 3 people will get zeros, because nothing got turned in. I cannot give points for nothing. All right. Any questions about the nested loop homework assignment? Okay. Now, if you don't get a lot of points, or if you miss the key concepts of this one, I would not get too discouraged. Okay, it is possible, the first time you just did not get the concept. So what you need to do in that case, okay, I'm not saying that you is getting a score that you do not like, but I'm saying that in case you get points deducted and you get less than 1/2 of the points available, what you want to do is to understand what did you miss. Okay, did you miss the meaning of the end of the loop? Did you miss what happens when the condition is true or false, or what? That's the key that's the key idea. Yep, go ahead.
Is there a way to find the solution that you just did, like to go back and look over what we just did?
You can watch the whole video,
The video.
or you can also download a file that I will be uploading at the end of the class or sometime today. Yep. That's why I'm saving it. And that's why also, I think watching the video may be more helpful, even though it takes more time, because I did work on it step by step and try my best to explain each step. So if you just look at a file, okay, let me switch back to the file here. If you just look at this solution here, I mean, it is correct, it's complete, but it doesn't tell you why those numbers are there. But if you go over the video again, of course, there's nothing added to the video. I'm not going to go home and actually, add some additional annotation to the video. But when you watch it again, at least you can pause, you can stop it, and say, okay, but what did he mean by da 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 da? And then you can look up the notes, and then see if you can get a better understanding. Then you have an example, and also the explanations in the notes, so you can try to see if you can get a better understanding that way. But it's much better if you do the homework and recognize, oh, okay, I did not quite get the same trace as the solution here, and address the problem here and now, rather than waiting until the first exam. Because with this class, you have to clear all these concepts right away. You cannot just wait until, oh, I'll deal with it when we have the first exam. It really doesn't work that way. Okay. Any other questions? Nope. Okay. So I'm starting to fall behind a little bit in terms of grading. So if you don't see your score updated, for a few days, don't get too alarmed. But what you need to do is to compare your solution to my solution. That's the one thing that you definitely want to do. If it looks exactly the same, that means you got it. Okay. If it looks a little bit different, then you have to look at the differences and try to explain. Okay, is that a superficial difference, or is it a real difference? Okay. In this case, I don't think there are anything that is superficial. In other words, line 8 and line 10 should never be traced, because those lines are ambiguous. Okay, if someone tells me that I'm on line 8, does that mean you're at the end of the action of a loop, or does that mean you're getting out of the loop? And while doesn't say, it's ambiguous. So I don't want people to trace line 8 or line 10. If you see differences like, oh, I have one here and I have another one here, that means you just forgot to update the value of z properly. You forgot that you already got a value of 1 here. You might have looked up here and said, oh, okay, it had a value of 0, so I'm incrementing that to 1. That's not good, but it's not too bad either. It's just a careless mistake. So what you need to do is to compare my solution to yours. So even without knowing the score, you will still benefit from the homework assignment. I'm going to save this, and and we'll move on to the next homework assignment. So I'm giving you a new homework assignment today. So at any time you have about 2 active homework assignments. Trust me, grading it is harder than you doing it. Grading is like looking at 40 something, 50 answers, over and over again, and figure out, okay, is this right? Is this wrong? If I were to give you guys all or none, in terms of scoring, that would be easier. Oh, the row sheet is here. But since I did, agree to give you guys partial credit, that makes my job so much harder. Because I cannot just take a quick glance and go, oh, this is wrong, 0. Okay? I actually have to go over it and find out, okay, where did it go wrong? Was it a concept issue, or was it a careless mistake? So those are the things that makes it kind of difficult for me. There you go. All right. So you already know about the assignment statement pre and post condition assignment, because we talked about that on Tuesday. So today, we'll start on something a little bit different, conditional statements. So as usual, I will show you the homework assignment, and then we'll talk about the concept. So hopefully, when we talk about the concepts, it will sink in better. Okay, you can see the format is almost the same as the previous one for each applicable line. So this time I choose the word applicable because there's one line that is not applicable. Yep.
I have a question offhand on the homework before this.
Mm-hmm.
About how many lines is it going to be done? I mean,
it depends on how you write it. I have no idea.
I'm saying because when I look at my homework, I'm like, did I skip a line or not? And that
I would say somewhere between, I think it will need about 20 lines or more to.
Because each pre has a question you answer. Do you forget or
and then you carry on the actual derivation. And then so on, so you would need about at least 20 lines.
Okay, and those are the only 2 things. Do you forget or substitute, right?
Well, you kind of have to go through, look at the one that I worked on Tuesday. I will upload the file. Okay. It's not online yet, but you have to kind of go through that and see how I worked on it, and then you can get an estimate of how long it will be for you too.
Okay.
All right, so moving on to this one. Now this one is a little bit different because it is a conditional statement. In other words, we look at this code here, and then we ask ourselves, if I tell you something about the precondition of line 1, if I tell you before line 1 executes, this blah, 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 blah has to be true, you have to tell me after line 5 or after we get out of this conditional statement, what has to be true at that time. Okay? And the precondition that I give you is over here. Assume pre1, the precondition of line 1 is x is greater than 0 and y is greater than 0. So the question now is, based on that assumption, what can you say when this is all done? That's the question. Actually, I think this is a little bit, there's a little more to it. I'm going to add one more condition to it. It really does not change the complexity of the homework assignment, but just for correctness' sake, you know, this makes it more, this makes it better. Okay, so let's see. I'll just leave it like this. That's fine. Okay, so no change to it. It's still the same as before. Because I worry that someone might have started on this one already and go like, no, don't change it. I have to update my homework. Yeah. Some people do that. I mean, some people check on homework assignments like every 5 minutes and, oh, there's a new homework assignment. Let me start on it. I know you guys have super duper smartphones now, so I know some people can actually do this on their smartphones. Okay, so here's the big question. If I only tell you about stuff like this, which is pretty abstract, okay? It doesn't tell you exactly what is the value of x. It doesn't tell you what is exactly the value of y. It doesn't even relate x and y together in this case. So the question is, how do I know how, you know, what x will look like and how y will look like at the end of this entire thing? That's the question. Yep.
So basically we're going to do 2 depending on if it's greater or lesser or whatever.
Correct. Actually, I changed my mind again. Has anyone started on this one?
Yes.
Well, because it is you, I know it's okay to change it. Oh. No, but it really is one of the more important conditions. You know, it's not really that bad. Okay, it's all it says is x has to be less than 2 times y. That's all. I mean, that's it. That's the only change I have to make. All right. So that's your homework assignment, and so what we'll do is we'll go through some examples and figure out, you know, when we have a conditional statement, how do we deal with it in terms of figuring out the precondition and the post-conditions. And I'm changing the way I present this material from past semesters too. So what I'll do, I figure out that there's a really good editor. It's called, what is it? Mousepad. Instead of Notepad, it's called Mousepad. And I will choose a slightly larger font so that we can all see better. And save the file first so that, you know, it can remind me where to save it again later on. It's just a text file.
Line numbers on, please.
There you go. So you guys can refer to the line number when you have a question. Very good. All right, so I'm going to give you guys an example first. Line 1 is if x equals to 0, then line 2 is y gets a value of 3. Line 3 else line 4, y gets a value of 5. Line 5. Okay, that's a fairly simple algorithm. I don't think we have to trace it to make sure that we understand this algorithm, because by now, I think we should be able to read the pseudocode and understand the meaning of the pseudocode. Is that okay? All right. So, the first thing is, what can I say if there's nothing specific about x that I know of before line 1 executes? How do I state something like that? we talked about that on Monday already. I mean Tuesday. What expression has to be true regardless of what the variables are? Yep. True itself.
What?
True. True itself is an expression that has to be true regardless of what the values of the variables are. Does it make sense?
Yeah.
Okay. So if I don't know anything about x or y or any of the other variables, I can say pre-1 is true. This is the most general statement you can say when you don't know anything about any variable at that time. Because true is the only expression that can be true when there's nothing else you know about the variables. Now that also shows you that maybe sometimes the precondition of some statement can be false. Right? I mean, if pre-1 in this case can be true, doesn't it, isn't it curious that sometimes maybe in some cases the precondition of a statement can be false? And the answer is yes. Okay? In some cases, the precondition of a statement can be false. The implication of that is that statement is not reachable in the execution of your program. You can never get there. Yep, go ahead.
So you're saying then the program would never initiate or whatever if it's false?
When the precondition is false, that means that statement is not reachable. You can never get to that statement, regardless of how you arrange your other variables. You can never get to that. I can show you guys an example like that. It's called a dead branch, but it's really easy to make dead branches, when we have multi-branch conditional statements. So we'll handle that. We'll come back and talk about that later. Okay. Now, what if I don't tell you anything about this, and I'll just say, this is mumbo jumbo. Mumbo jumbo. Okay? All right, well, let's start with that. Okay, so the precondition of line 1 is mumbo jumbo. I don't even know what it is. Okay? It's not true. It's not x is less than y. It's not x is greater than y. It's not y equals 1. It's mumbo jumbo. Okay? I do this intentionally. And my next question is, what is pre-2? Now, you have to think about this in a more kind of graphical way, because I think having a picture in your mind will help when you try to understand something like this. Yep, go ahead.
You would have two answers, right?
No, pre-2 means, what do we know right before we execute line 2? Yep, go ahead.
Mumble jumble.
Uh-huh.
And x is equal to 0.
Exactly. Okay? So let me post the answer now, and then you guys tell me whether that seems correct or not. You got it? Questions? Questions? Yes, go ahead.
Are you going to use post for 1 or not?
Yeah.
No, it is not post 1. Okay? I specifically asked for pre-2 instead of post 1 because the reason why you go to line 2 is not because line 2 follows line 1, but because of the control structure, because of the way a conditional statement works. So that's why we never refer to it as post 1. We only refer to it as pre-2. Okay? There was other questions? No? Okay. All right. So let's draw a picture if I can find a dry marker pen.
There's a bunch.
Right there on the corner of the board.
Okay. Okay, so once again, this is not going to be captured. I'm not going to use my cell phone to take a picture and then upload it. But you might want to draw this at the same time too. Okay, so here's a general conditional statement structure. I hope you guys still remember this. Okay, it's a branch. You come in from here. You can make a decision to go either way. You perform an operation in either branch, and then the two branches will merge before it gets out of the conditional statement. But when you need to determine which way to go, one branch is labeled true, the other branch is labeled false. But in order to decide which way to go, you must have a question of some kind that only has true and false as answers, as possible answers. Is that okay so far? This is a really quick review of what a conditional statement is. So in this case, what we have is, the question is x equals to 0. Is it true or is it false? If it is true, we go this way, and then we perform the operation of y gets a value of 3. If the answer to the question is false, we go to the other branch, and then the action is to assign a value of 5 to y. Either way, you will get out after the assignment to y. Are we doing okay so far with this? Okay. So the question now is, on what is given to you is, at this point here, as you pass through this loop here, this little indicator, we say that we know the condition mumbo jumbo is true, whatever it is. So now the question is, what is pre-2? This is line 2. So pre-2 is looking at this point here and ask, as we pass through this point here, what do we know for sure has to be true?
X equals 0.
X equal to 0 has to be true, otherwise we won't be here. But what about mumbo jumbo? Is mumbo jumbo guaranteed to be true right before we get to this statement?
Yeah.
Did I have a chance to change anything?
No.
No. I just evaluated a comparison. And comparing something does not change the value of any variable. And as a result, whatever mumbo jumbo is before line 1 still has to be true at this point. So that's why the condition at this point, or pre-2, is mumbo jumbo and x equals to 0. Okay? Now I want to do it like this, because a lot of times, people forget about the mumbo jumbo. Okay? If I make it, a very specific thing, like, x equals 10 or x does not equal to something, it's too easy for people to ignore. But when I use mumbo jumbo, people tend to remember, oh, mumbo jumbo, I can remember mumbo jumbo.
It basically means true, right? Everything before is true.
Everything that was true before still has to be true at this point. But in addition to that, I also know that x has to be 0 when I'm about to execute line 2. Okay? For the same reason, can I do something about pre-4, the precondition of line 4?
Yes.
The precondition of line 4 is about the same thing, except it is on the other side, right here. Yep.
X is not equal to 0.
X does not equal to 0, but what else do I know?
Mumbo jumbo.
Mumbo jumbo, right? Because at this point here, I haven't got a chance to change anything yet. So whatever was true before I evaluate this condition still has to be true, except at this point I also confirm the condition is false. Is that making any sense? Okay? Yep, go ahead.
Can you give me an example of what mumbo jumbo might represent? Like
Okay.
a particular value or what?
It can be very simple. I'll show you an example soon enough. So in this case, pre-4 is x does not equal to 0, right? We just confirmed that because we took this branch and we are about to execute line 4. Okay. Let's be a little bit lazy and just say post 2 is something more mumbo jumbo. Okay, and we'll say post 4 is even more mumbo jumbo, because that's not my focus at this point. That's not my focus. In other words, all I'm saying is, well, I know how to derive the post condition from the precondition at this point, but I don't want to do it. I'm just going to say this is more mumbo jumbo, and this is even more mumbo jumbo. Okay? The big question is, what is this part here? This is not going to be even more mumbo jumbo. Okay? Because I know how this relates to these two. Yep, go ahead.
Y equals 5?
No. Okay, I'm standing right here. Okay? And when I stand here, I do not remember which way I came from.
Either or.
So
Well, it's or, but not
X
either or.
equals 0 or X does not.
It's mumbo jumbo and y is equal to 3 or y is equal to 5.
Okay, it is post 2 or post 4. Okay, it's a simple or, it is not an exclusive or. Well, now why is it not exclusive or? I mean, according to this picture, I can only come from one way or the other way. So the logic seems to dictate that this or here should have been exclusive or, because I can only come from one way or another way. Well, that is true. From the control structure point of view, I can only come from the then branch or the else branch. But from the logic perspective, they can be the same condition. Okay? Now, if they are the same condition and you put an exclusive or, that won't work out. Because when you have an exclusive or, you need only one of the two conditions to be true for the whole thing to be true. Yep.
What is an exclusive or like? Is that maybe?
Exclusive or is commonly known as either or in English.
Okay. And since they effectively do the same, it can be either of them. Just one or
Correct. Now let me give you an example. Okay, if I say the sky is either blue or I'm trying to think of an example where it can be both be true. So
Black. Or is it cloudy or not?
Do you want a hamburger or
Ocean.
fries for
okay,
lunch?
the sky can be cloudy or it can be raining frogs. Okay, that's an exclusive or. Okay, because I use the word either in this case. So that means, what is the truth false value of that statement when the sky was both cloudy and it was raining frogs? That would make the statement false, because the statement says it can only be one or the other. What if the sky is clear and no frogs was falling from the sky? The statement is false again, because the statement states that it has to be one or the other case. It has to be cloudy, or frogs has to be falling from the sky. But like today, if the sky is clear and no frogs is falling, that makes the statement false. Or if you have clouds and some cargo airplanes just decided to open its cargo bay and it was transporting frogs, okay, that will also make the statement false. Worse things have happened. Worse things have dropped from the sky from airplanes. I'm not going to get into details of that.
Or keep on dropping.
Yeah, I think it came from a passenger airplane. It's bad. You guys some of you probably have heard of that story. Yep. Okay, so that's why it can only be an or, but not an either or, because post 2 and post 4 can be exactly the same condition. Okay, so in this case, since I used those funny words, so that means I have to replace those funny words here and replace the other part with another funny word. That. Okay, so I'm trying to use just the mumbo jumbo, more mumbo jumbo, and even more mumbo jumbo, just so that we don't focus on the derivation of the actual conditions and we focus on the structure of a conditional statement. Is that part okay? Just focusing on the structure of the conditional statement? Yes? Okay, so now let's go back and be a little bit more serious this time and try to figure out what exactly is mumbo jumbo and so on and so forth. Okay. In fact, we'll use another test case here. The other test case is if x is greater than y, then z gets x, else z gets y, and if. And I have to give these line numbers. Have we seen something like this before? And what does this algorithm do? What does it accomplish? Z is the maximum of the two variables. Very good. So we have seen this before. And remember when we first saw this algorithm, I went through a few test cases. I went through a few traces and said, it seems to work. I also pointed out and said, but how do we know the next test case will still work? And my answer was, we don't know. Okay? You can test this with 200,000 test cases, and the next one, 2,101, may not work, and prove this algorithm to be incorrect. So now we can prove it to be correct once and for all. Okay? So we'll use what we just learned and actually prove that in this case. So in this case, the precondition of line 1 is going to be true. What that means, as I said a little bit earlier, is that I don't even need to know anything about x, y, or z. They can have any value, but I can still show that this algorithm is correct. So given that, what is pre-2? Now, as much as we want to say pre-2 is just x is greater than y, don't do that. What you want to do is to restate pre-1, and then you confirm that x is greater than y. The reason why we want to do this is because we want to, basically this, line 28 of this text file is not specific. Well, this part is, x is greater than y is specific to this particular code, but this part is not. It's simply saying whatever was true still has to be true, except we also know that x is greater than y in this case. Yep.
Do we put pre-1 or do we just can we put true also?
I would put pre-1 first, and then the next line you expand what is pre-1 and do it like this. So I'm showing you what you need to do with your homework assignments in terms of what steps I am expecting. So for the most part, you can just copy and paste what I have here and just change it enough to make it suit the homework assignment. Oh, we have never seen anything like this. True and something. Can we do something about it, or do we have to keep it the way it is? Let me ask you a question. What is 1 times x?
X.
It's x. What is 1 times w? It's w. Why do we know that?
It's math.
Kindergarten.
It's math, it's algebra, okay? In algebra, does 1 have a specific name or a specific role in multiplications?
No.
It's called the identity of multiplication. In other words, we know that 1 times whatever is that whatever. Okay? And guess what true is in the case of conjunction?
1.
It is also the identity. In other words, I can say true and whatever. This is the same as just whatever.
Because the statement is true and true is true.
Exactly. So the way we can prove this is a whole lot easier than that. This is an axiom in algebra. In other words, you just take it for granted. Okay? But this one is not an axiom. You can actually prove it by the definition of conjunction. So let's kind of talk about this a little bit. So this is a slight detour, and I'll put the detour ahead of the derivation so it doesn't interfere. Okay. We're talking about and, right? So let's take a look at the truth table of and again. We have x and y representing the two sides of conjunction, and then we want to figure out what is x and y. This table is by definition. This is the definition of conjunction. X can be true, y can be true. What is true and true? True. X can be true. At the same time, y can be false. What is true and false? And then we have false here, true here, and the answer is false. Okay, we have false, false, and then we have false here. Okay, so out of this truth table, these two is irrelevant in this case because I know the first one is true already, so I can forget about the cases when the first one is false. So I can focus on the first 2 rows. With the first 2 rows, do you notice that whatever y is, the answer of the conjunction is also exactly the same as y? Yeah? When y is true, the answer is true. When y is false, the answer is false as well. So that means x and y is equivalent to just y when x is true. And therefore, we can make a statement like this. True and x is greater than y is really just the same as x is greater than y. Okay? So that's why true is the identity of conjunction. And as a result, we can simplify this and take out true and, because true and whatever is whatever. And the reverse is true too. Whatever and true is also just that whatever. just like W times 1 is W. How many people in this class enjoy algebra? Very good. Okay. If you enjoy algebra, you should also consider taking abstract algebra. The only difference between regular algebra and abstract algebra is in abstract algebra, the 1 is not a 1, and the 0 is not a 0. They're just identities of the respective operation. But it's fun. It's a lot of interesting. It's very interesting, and it is related to programming as well. All right, so that's good. What about pre-4? Okay, same thing. Pre-1 has to be true, and in this case, the condition of the conditional statement has to be false. So I would start with not the condition of the conditional statement, just to emphasize that this is the negation of this. Okay, and I would stick with pre-1 as well, just to state that yes, whatever was true before the conditional statement still has to be true if I am just about to execute line 4. The next line, you can expand it. Pre-1 is just true. Not x is greater than y, there's another way to say that. You can say x is less than or equal to y. You can say y is greater than or equal to x. There are a couple of ways to take out the negation. And then we can do the same simplification here and just say that x is less than y, less than or equal to y. Okay. Do we have any questions at this point regarding the derivation of pre-2 and pre-4? Pre-1 has to be given to you, but pre-2 and pre-4 are derived. Yep.
We can't use the not in the next one. We have to say it's not equal.
You mean on which line?
39.
On 39.
40, do we have to take the negative out?
The negative?
Talking about the
The
negation.
not, do you have to take it out and rephrase it like that, or?
It's easier this way, because later on you will see why taking out the negation is easier. Generally speaking, if you can take out the negation and just change the operator, the comparison operator is a preferred way of doing things, because it's easier to say x is less than or equal to y than to say it is not the case that x is greater than y, even though they mean exactly the same
So
thing.
essentially we
Okay,
just
so
want
we're
to
doing it for a reason.
simplify.
Yeah, it's a simplification, but
Okay.
for the most part, it's only for your purpose, because logically speaking, they are exactly the same thing. It's just that one is easier for us to interpret than the other one.
Okay.
Okay, now, how do we get to post 2? Okay. Oh, I have no idea how we can get to post 2. We have never tried to figure out the post condition of an assignment statement inside the conditional statement. Does it matter? What do you need to figure out the post condition of an assignment statement?
X is z, x equals z.
No, but what do you need to derive that?
Precondition.
The precondition. Do we know the precondition of line 2?
Yes.
At this point we do. All right. And there are two questions that you have to ask, potentially 2 questions that you have to ask. What is the first question that you have to ask when you are dealing with an assignment statement?
I just want to ask, is you could only do post 2 after you did the pre-4?
No, you can swap the order. I just think that your pre-2 and pre-4 are closely related from the structural perspective, and that's why I do the pre-2 and then the pre-4. But when you work on this, you can work on pre-2, post-2, pre-4, post-4. I mean, that works just as well.
So it's the assignment statement.
Okay, it's an assignment statement, so we need to ask a question.
Left hand side refers to right hand side.
Does the right-hand side refer to the left-hand side, right? Okay. Does the right-hand side refer to the left-hand side on line 2? What is the answer to that question?
No.
Nope, no, false. Okay. So do we need to ask the second question, whether there's an inverse function and all that stuff?
No.
Nope, because if it does not refer to the other side, it's not reversible. If it's not reversible, what do we do?
Forget.
Use the forget rule. Okay, use the forget rule. Okay, what is the general form of the forget rule? You have to say apply the forget operation on the precondition of this line. And what are we forgetting on that line? z. Okay, whatever component mentions z, we have to forget that because we are changing the value of z. Do we have anything else to add to it after line 2?
X is greater than y.
How about that? Or no, I can reverse that. Isn't that true too?
Oh, yeah.
Because what does line 2 do? Line 2 is an simple assignment statement. We take the value of x and we update z with that. So it is guaranteed that after line 2, that x and z will have the same value. We may not know anything about z, excuse me, we may not know anything else about x, but we know for sure that z and x must have the same value at that point. Are we doing okay? Does this sound like, is this kind of give you the feeling of deja vu?
Yes.
It should. If it does not give you the feeling of deja vu, something is amiss. Because we just talked about this on Tuesday. Okay? So that means, well, this is great because this means when assignment statements are nested inside a conditional statement, it does not change how we go from the precondition of the assignment statement to the post-condition of the assignment statement. That's great because we don't have any more special cases. Okay? What you have learned before still applies. Okay, so now we expand what is pre-2, and pre-2 is a fairly simple thing. It's just that x is greater than y. Is there anything to forget in this case?
No.
There's nothing that mentions z, so there's nothing to forget. So we get to keep x is greater than y, and at the same time now we also know that z equals to x. Okay, that's good. Post 4 is almost exactly the same thing. Yes?
Why do you say in 45 forget that x is greater than y?
No, I'm not saying that. I'm saying forget all the components in this condition that has any mentioning of z.
I'm still not.
Okay, you take this expression here, which can be simple like this, or it can be long like this. Okay?
Oh,
And then you say,
okay.
well, if there's any comparison involving z, you have to take those comparisons away. Because the relationship of z with other variables can change at this point, and none of those can be guaranteed anymore.
Right.
Yep.
On the line 44, don't you have to put x is greater than y also? That's true on the line 44.
No. You cannot do that because x is greater than y is captured in pre-2
okay.
already.
Okay.
And then you have to apply the forget operation because if this is x is greater than z, then you do have to forget it.
I missed the pre-2 thing.
Right?
And the z is equal to x stays the same.
Well, that's something that you can confirm after the forget operation. And that's why it is important. It's very important to remember to put this part outside of the forget, because otherwise it's just pointless. If you put this inside here, that is just pointless because you just forget it as soon as you put it there. So the and part, and z equals x, has to be outside of the forget operation. Okay? For post 4, it's about the same thing. I mean, at this point, this stuff should be boring because it really is the same thing. Okay, does the right-hand side refer to the left-hand side on line 4? The answer is false. We have to use the forget rule. And whenever you use the forget rule, you have to use pretty much the same template. The results will be different, but the template will still be the same. You just have to change pre-2 to pre-4. And in this case, it is the same because if you look, oh, okay, I take it back. This is now y. When you use copy and paste, there's actually a lot of things you have to worry about because you have to remember to catch every little thing that is different between the two cases. Whereas if you start typing from scratch, you won't have that problem. Okay. X is less than or equal to 4. X is less than or equal to y does not mention z, so there's nothing to forget. And we have to add z equals to y at that point. Are we doing okay with post 2 and post 4? That's really old stuff, well, not really old, but that's old stuff that we talked about on Tuesday already. And this is also a good reminder of what you need to do for your homework assignment to answer your question. If you have a forget operation, that statement should take up at least 5 lines, like in this format. Okay, so now we're moving on to the really good part here. What is post 5? What do I know when this algorithm is done executing?
Post 4 or post 2?
Exactly. So because it's over here, let me see if I can show the whole thing at the same time. Just a little short of that. Okay, there we go. Okay, so we are trying to ask, when we get out of the conditional statement, what do we know? Well, according to the earlier example, we know that we are just taking the post condition of both branches and relate those with a simple OR. Okay, so we'll go ahead and do that. So you don't want to just plug in the actual thing. You want to say it is post 2 or post 4, because this part is due to the structure of the conditional statement. And then you can expand that, which in this case is not too bad. Okay, now I would do this first. I would put parentheses first, because each one is a conjunction by itself. So post 2 is a conjunction, post 4 is a conjunction as well. If you do not put the extra parentheses, then someone may have the question of, okay, if you have A and B or C and D, when do we evaluate the and when do we evaluate the or? When you do multiplication and addition in normal math, you know that you have to do the multiplication first. It really is the same thing when you deal with logic. Conjunction has a higher priority than disjunction, but to avoid any potential problem, just use extra parentheses. That will just clear everything up. Okay, any questions about this part? Now, when you're writing actual programs in your cisp300 class or some other classes, I personally still prefer extra parentheses, because there are editors out there that can match parentheses for you. So that means if you put your cursor on a particular open or closed parenthesis, it will automatically highlight the end of it. And having those extra visual help can really help you debug your program, because now you can visually see, oh, this is the beginning of this big, long, messy expression, and there's the end of it. Without that extra parentheses, and you're just relying on the priority or the precedence of operators, then it's much harder for you to visualize and go like, okay, where's the end of this operation? It's somewhere, but it's hard to see. This way, it is really easy to see. Okay, I'll just leave it like this. Can someone tell me whether that really is the definition of the maximum of 2 variables? Is that the property of Z when it is the maximum of X and Y? Let's forget this for now, okay? So let's detour. Yep. Go ahead.
Nothing. Sorry.
Okay, let's try to answer this question instead. What does it mean when Z is the maximum of X and Y? I'll let you guys, give me some, suggestions. Yep.
What if they're equal? Is that what you're getting at? Special case?
No. I'm asking, mathematically speaking, how do I express Z is the maximum of X and Y? That's the relationship between Z, X, and Y.
Z is greater than X and Y.
Okay.
Greater than or equal to.
Okay, so let's take that as a starting point. Z is
Greater than X and Y.
okay. So I take it that this is what you meant.
Yeah.
Okay, but that's not the maximum, is it? Okay, let's think about it. Okay, let's think why this is not the proper definition of maximum. Because I can easily generate one case here. X is 1, Y is 2, Z is 3. Is 3 the maximum of 1 and 2?
Well, that's if this added together, but individually then.
No. Z is not the maximum. I mean, in this case, 3 is not the maximum of 1 and 2.
Can you say Z is equal or greater than X, or
Yep.
Z is
Okay, that's a good change.
If Z equals X, it's greater than Y, and if Z equals Y, it's greater than X.
Okay.
or something like that.
Okay, that's actually a very good thing. Say that again.
If z equals x, then it's greater than y.
Then
It
x.
says x equals.
Then z is greater than y.
What about this? What about, if x is greater than y, then z equals to x.
Okay.
Okay, we'll replace this with the implied, operator.
That means
Does anyone know the implied operator from your math classes, or do they talk about this in math? No? Okay. In that case, we have to kind of work on this,
In
from
geometry, they use imply.
in geometry.
Yeah.
Okay, because imply is a very useful operator. It's a Boolean operator, just like and or, except it has specific meanings. Okay. Okay. The first one didn't work. Okay, this one didn't work. What if we just add, z is greater than or equal to, and z is greater than or equal to? Would that work? That won't work either, would it? What is missing here? Because if z is greater than or equal to x, and z is greater than or equal to y, the same test case will still be true, right? Because if I pick x to be 1, y to be 2, and z to be 3, it will still make this expression true, even though 3 is not the maximum of 1 and 2. Yep.
Change and to or.
Change it to or? You mean change this one to or?
Yeah.
That makes it even worse. That makes it even worse because now I can say this will make it true. 1.5 is the maximum of 1 and 2, because this combination of value will make this expression true, even though z is not the maximum of x and y. Yep, go ahead.
If x is greater than or equal to y, then
X.
z is
Equal to x.
Z has to
X.
equal to x.
yes.
Okay. Okay, so let's take that. Okay, so what you said is if x is greater than or equal to y, that implies z equals x. Right? Now the question is,
Else z equals y.
okay, else, okay, so that means you have an or to deal with the else, okay? Because it's or else. Or x is less than y implies z equals y. Right? The equal and greater than symbol together means imply. Okay? This is the correct answer. Okay? This is in fact the correct answer. The big question now is, but tag, we only talked about the 3 logical operators. What are the 3 logical operators that we have talked about? And, or, and, not. And not, negation. And here comes a new operator called implies. Bummer. Well, not exactly. What does imply mean? So you guys are leading me down a kind of interesting path here. Okay, because for many years I tried to talk about imply, implied by, and equivalent to, and yet most of the time people don't understand the differences between those two, or why we need to understand the differences. Yep, go ahead.
Imply means if the first one is true, then it implies that the second one is true.
Okay.
But it doesn't necessarily imply if the second one is anything but the second one. If the second one is false, you don't know the first one.
Okay, that's exactly true. Okay, so let me give you an example. Okay, and I'll do it like this. Okay, Luke breaks a window. Luke is my son. Implies Luke gets punished. Okay, let's think about that statement. It's a statement. At the before I left for work, I told Luke, if you break a window, you can get punished. Punishment, at least will start with no, DS time, no we time. That's a minimum requirement. And depending on the size of the window, it will also, have other stuff tagged on to it. Okay. So we, in English, we don't use this symbol in English. I mean, never use this symbol in your English paper. Okay, your English professor will say, what is this? It's implied. What do you mean? It's implied, right? And you'll get a big fat 0 in that essay. But in the logic class, that's what we use. But in English, what does this mean? It means if Luke breaks a window, then Luke gets punished. Is that okay? Just establishing the English equivalence to the logical operator here. But what does that exactly mean? What does it mean when I do not break my words, when I'm consistent? Okay, so let's look at the 4 scenarios that can happen in this case. The 4 scenarios that can happen in this case, and let me add one more column here, tag is consistent. Okay? Because consistency is a very important part of parenting and being a professor too. So 4 cases can happen. Luke can break a window, and Luke gets punished at the end of the day, and can I be consistent with my words in this case?
Yes.
I'm consistent. Luke breaks a window, and he gets to do everything that he wanted to do. He didn't get punished. Would I be consistent with my words?
No.
Luke did not break a window, and he gets punished. Am I consistent with my words? I'm still consistent. Because I didn't say the 200 and some other reasons how he can get punished. Maybe he burned down the house. And magically, none of the windows got broken when the house got burned down. Maybe he flooded the house. That's a better example, right? I mean, he turned on the water and didn't, forgot to shut it off, and we got a major flood in the house, which, by the way, is actually more costly in some cases than a fire. Okay, and he gets punished. I'm still consistent. I never said anything about what happens when he did not break a window. I never said anything about that. So that means if he did not break a window and he did not get punished, I'm still consistent. Is that okay? Now this is really, really important because this is the cornerstone of implication, okay? The understanding of implied by, and equivalent to. And those are things, even though they sound about the same thing, they're not the same in terms of logic. Is that okay? Okay. So I'll just add one more thing here, which is the English version of this. If blah, 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 and blah, 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 blah. Okay. Let's look at, I'm going a little bit overboard here, but I think it's useful. What if I change my word to a phrase and say, only if Luke breaks a window, then he gets punished? So let's look at the implication of this and see in what cases I will be consistent with my words and in what cases I am not consistent with my words. He broke a window and he gets punished.
True.
Am I consistent?
Yeah.
Consistent. Oh, by the way, the symbol is now a little bit different. It's similar to the other one, except it goes the other way. It is the implied by. Okay. And let's use the same second case. He broke a window, he did not get punished. Am I still consistent? I'm actually consistent. Okay? Because what this means is Luke breaking a window is a necessary condition to get punished. But there may be a whole bunch of other conditions that also have to be true in order for him to get punished.
So basically, the right side comes first. If that's false, then
So, if you said only if Luke breaks a window, only then Luke gets punished, then you'd be inconsistent.
Say it again?
If only if Luke breaks a window, then only then he gets punished. Then
That's
you'd be
that's also a
inconsistent.
different case. That's equivalent to. So in this case, it is just only if Luke breaks a window, he gets punished.
so he gets punished because he breaks a window.
It's sort of like
The one way to look at this is if he gets punished, I guarantee that there's at least one broken window.
That's what I'm saying.
Yeah.
He got punished because he broke a window.
This is breaking a window is a necessary condition, but it's not a sufficient condition to get him get punished. Okay? Yep.
This sort of saying like only if he uses a bat to break the window, then he gets punished. In that case, he didn't use the bat, so he didn't get punished. Like that.
No, it simply means breaking a window is a necessary condition to get punished. He can flood the house, burn down the house, but as long as there's no broken window, I do not have ground to punish him.
Since he didn't get punished means he didn't break the window.
Exactly, that is exactly what it means. So let's finish this truth table here. He did not break a window, and yet he gets punished. This is the only time I am inconsistent with my words. Okay. Now I know this looks confusing because in the normal English usage does not seem to make much difference between these two cases, but in logic it does. Okay. So if you want to look at this yet another way, you can say this is a sufficient condition for this. And then in this case here, this is a necessary condition for this. Is that a better way? Is that better? Looking at it from the perspective of what is sufficient and what is necessary. Just because breaking a window is a necessary condition doesn't mean it is already automatically sufficient. The last one is this: if and only if, which in logic is also called IFF, because mathematicians do not like to use a lot of words. So in this case, what do you think? Let's take a look at all the cases here, and we'll put the then here. And this time it is bidirectional. Okay, so I'll take out all the answers, and we'll figure it out together. Okay, so what I said in the morning was, if and only if Luke breaks a window, then and only then he will get punished. Okay? So what does that mean? He breaks a window, he gets punished. Am I consistent with my words?
Yes.
He breaks a window, he did not get punished. Would I be consistent?
Yeah.
No.
No. What about if he did not break a window and yet I punish him?
No.
No. What if he did not break a window and he did not get punished? I will be consistent. Okay? So these are the three cases that people can get confused about, all the time. If then, only if then, if and only if then. But in terms of necessary and sufficient and stuff like that, what would I describe this condition here? This would be sufficient and necessary for this to happen. Yep.
On row 80, you said that the only if statement, if he doesn't break a window and he doesn't get punished, how is that inconsistent?
Oh, you mean this one here? Oh, I got it wrong.
Good.
There we go. Thank you. All right. All right. So we have several ways to call these things. Sufficient condition for blah 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 is one. You can also say the first one implies the other one. In this case, a necessary condition for the other case to happen, it can also say this is implied by. Okay, Luke breaks a window is implied by Luke gets punished. Because if you at the end of the day, and then you see, and then you look at the statements, what happened to Luke on that day, if he breaks a window and he gets punished, then I'm consistent with my words. If he did not break a window and he gets punished, in this case, I am not consistent with my words. In this case, sufficient and necessary condition, it is basically is equivalent to. Okay? In other words, Luke breaking a window, logically speaking, is equivalent to Luke getting punished, because those two tie in completely. If one is true, the other one has to be true. If one is false, the other one has to be false. Okay? So now that you know this stuff here, we know that in this case, now getting back to this part here, because all we wanted to do is to say, but what do we do with the implication or the imply operator? Well, when you know the truth table looks like this, we can actually try to figure out how to do this using the operators that we know already. So here's the detour. We have x, y, and then we have x implies y. Okay? Just a quick summary of what implies means. True, 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 false, 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 true, true, false, false, true. Is that right? This is just a quick capture of the logic from above. So the next question is, can I use just negation, conjunction, and disjunction, somehow mix those things together and have the same result as x implies y?
Yes.
The answer is yes. What is it? Okay? Well, I know this because I teach this class. But the big question is, am I right or am I wrong? Is there any way to double check tech? I mean, whatever class you take, you need to kind of have the mentality and go like, can I verify, the answer from, the professor? In this case, can you verify that I'm actually correct in this case? Not x or y is the same as x implies y. It will give me the same true, false values. And the answer is yes, it is easy. All you have to do is to work it out. X is true, not x is false. Y is true. So what is false or true?
True.
True. Okay, very good. We have a good start here. What about the second one? X is false. Excuse me. X is true because of this. So x is true, so not x is false. Y is false to begin with. What is false or false? False. Good. In this case, x is false to begin with. Not false is true. Y is true. What is true or true? True. And the last case, we have x being false to begin with. Not false is true. What is true or false? It's true again. In other words, I have just shown you for all the possible combinations of the input x and y of all four possible cases, x implies y, this is the definition of implication, turns out to be exactly the same as this expression here, which is not x or y. So that means x implies y is exactly the same as not x or y. Whenever you have this, you can replace it with this. Whenever you have this, you can replace it with the other one. I know I'm running out of time, so I'm going to go back to this part here. Just quickly, do that part. So what this means is not x or y, right? So this means, actually this is an AND operation here. Okay, is that making any sense? It is not the case that x is, so this becomes x is less than y or z equals x, and x is greater than or equal to y or z equals y. It still doesn't look like this, does it? Okay. In order to convert this, okay, but if you look at this one here, does it seem to suggest that z is the maximum of the two?
Yes.
It does, okay? So what we are missing that I cannot finish today is how do we connect this to the other one? Because I know the other one is correct as well. Okay, so we need to do some more, algebra, Boolean algebra in this case, to do the conversion. Yep.
Is line 60 still relevant?
Sorry?
The line 60, we still need that?
Line 60. You mean this one here?
Yeah.
That is not, that doesn't really do us any good. So we have to get rid of that. Okay. So we'll talk about this on next Tuesday. You can look at it as a brain teaser too, okay? If you guys want to make the connection, look at this one as a brain teaser, but don't forget your homework assignment that is due on Tuesday.
When is the test?
Next week we'll have a practice test, and then the week after that we'll have the actual test.
So next 2 weeks. Thursday we'll have the practice test.
Yeah.
And the following.
Yep. I did.
Okay.
Okay, so you might need to send me an email. Remind me about that. Yeah, because I remember seeing you on Tuesday too. So, okay, just send me an email.
Okay, thank you.
Yep.
Is any staff writing this class?
Well, I'm going to add everyone, who has been attending the classes, consistently. So just, wait for my, you just dropped it, something. So just wait for my email with the permission number. You need to go get the forms, but I'll add everybody who has been attending consistently.
Okay.
Yep.
I actually got the email to be added. Where do you go with forms?
The forms, you can get it from admissions and records, which is in the administrative building.
Okay.
There are 2 forms you need to get. There's one smaller form, which is the ad slip, and then you have the longer form, which is a petition form.
And I have to you sign it, right?
Yeah, I have to sign both, and the dean has to sign one of them too.
Okay.
Yep.
All right. I'll probably have that for you on Tuesday.
Yeah, it's not urgent, but
Okay.
getting it done soon would be good.
I sent you an email about the name tag image,
Uh-huh.
and I didn't figure it out, but there's a password,
Mm-hmm.
so I have to give.
The passwords?
Yeah.
Oh, the password.